In section 2.3, we look further into polynomials by dividing and long division and synthetic division in order to find factors and zeros. Okay, so the first thing we're going to do is long division. Fun stuff. We won't read through that. We'll just look at an example. That'll make it a little bit easier. So, starting with 2x cubed minus 11x squared plus 13x plus 15 divided by 2x minus 5. Okay, so what we do is we ask ourselves, how many times will this 2x go into 2x cubed? Well, 2 goes into 2 once, and x goes into x cubed, x squared times, okay, because x times x squared gives us x cubed. So we just need an x squared here. And when you multiply through, you should get 2x cubed, and if you don't, you know you've chosen the wrong thing. So 2x times 2x squared is 2x cubed. And then we multiply x squared times negative 5, so that's minus 5x squared. Then we subtract. So in order to subtract, I'm just going to change the signs in here. And so 2x cubed minus 2x cubed is 0. Negative 11x squared plus 5x squared is negative 6x squared. Okay, so next we ask ourselves, how many times does 2x here go into negative 6x squared? It goes negative 3x times. So negative 3x times 2x is negative 6x squared. Negative 3x times negative 5 is positive 15x. And let's see, we needed to bring down the 13x here. And so now we're going to subtract again. So I'm going to change the signs. Oh, this was supposed to be positive in here. And so we end up with negative 2x. Let's see, do I have room? Nope. Oh, goody. Okay, so let's see. Next, we ask ourselves, how many times does 2x go into negative 2x? Well, it's just negative 1 times. So negative 1 times 2x is negative 2x. Negative 1 times negative 5 is positive 5. And we needed to bring down the plus 15 from up top. And we subtract, so change the signs. And that gives us a remainder of 10. So our answer is what's up here with a remainder of 10 over what we were originally dividing by. So we have x squared minus 3x minus 1 plus 10 divided by 2x minus 5. Okay? So you'll see further on why this is important to us, but that's our solution so far. So looking at example 2, we're going to do long division again just to get a little more practice. So we've got x to the 5th minus 3x to the 4th. There's no x cubed or x squared in here, and so we need to leave spaces for that. So we're going to put 0x cubed plus 0x squared. We just have to leave spaces. And so then we've got plus 12x minus 33. And that is divided by x minus 3. Okay, so again we ask ourselves, how many times does x go into x to the 5th? Well, that's x to the 4th times. X times x to the 4th is x to the 5th. X to the 4th times negative 3 is negative 3x to the 4th. And then we subtract. When we do that, we just get 0. That's okay. And then we've got a 0 coming down and another 0. So we've still just got zeros until we get into the 12x minus 33. Okay, so we don't really need to worry about those zeros in there. We'll just ask ourselves now, what will multiply, or how many times does x go into 12x? Well, that's 12 times. And technically, we'd write that out further, but that's okay. It doesn't really matter. Okay, so 12 times x is 12x. And 12 times negative 3 is negative 36. And then we subtract. So we get a positive 3 here. So our solution is x to the 4th plus 12 plus 3 divided by x minus 3. Okay. One more example with long division, just so we get the hang of it. So we've got 2x cubed plus 2x squared minus 16x plus 32. And we'd have to move this over. That is divided by x squared minus 3x plus 4. Oh, my stylus is getting squeaky. Okay, so how many times does x squared go into 2x cubed? Well, it would be 2x times. And then we multiply through. So 2x times 2x squared is 2x cubed. 2x times negative 3x is negative 6x squared. 2x times 4 is positive 8x. And then we subtract. So we've got 8x squared minus 24x. So the next step is to ask ourselves, how many times does x squared go into 8x squared? Well, 8 times. So we've got 8x squared. And I needed to bring down this plus 32 from up here. 8 times negative 3x is negative 24x. 8 times 4 is 32. And then we subtract. And this time we get 0, which we're going to find out is a good thing in the future. And so our answer is just 2x plus 8 with no remainder. Okay, how do we divide using synthetic division? Well, the biggest thing with synthetic division is that there cannot be a number in front of the x. If there is, then we have to get rid of it somehow, okay? So that's the biggest thing there. And it's got to be just x minus c, okay? We can't divide synthetically by x squared minus 3x plus 4. We can divide synthetically, like example 2. And for example 1, we could change this to x minus 5 halves, I believe, and then do that. But on to example 4. You can read through this if you like. I find it easier just to do an example. Okay, so we're dividing by x minus 3. So in the little box, we put a 3. Okay, notice I use the opposite of what is in the factor there. Okay, and then we put the constants in front of each term. Okay, so our constants are 1, negative 3, 12, and negative 33. Skip a space. Draw a line across and a line just between the 12 and the negative 33. Okay, it's right before the last term. So that gives us our remainder if there is one. Okay, so here's what we do. We bring down the 1. Then we multiply. 3 times 1 is 3. And we put it up there. And then we add. So negative 3 plus 3 is 0. Oh, I left something out very important here. We'll just get rid of that. And I need to erase those. So there were some extra terms in here that aren't covered, like x cubed and x squared. So we do have to put zeros for those with our synthetic division. And then put the 0 and the negative 33 over here and still put our line down there. Okay, so back to this. So we added negative 3 plus 3 gave us 0. Then we multiply, do the same thing. 3 times 0 is 0. Add. Okay, and we keep going, and I won't put these arrows every time, but for now 3 times 0 is 0, and then we add. And I'm going to start with the arrows. 3 times 0 is 0, and we add. 12 plus 0 is 12. And then last, we have 3 times 12 is 36. Negative 33 plus 36 is 3. And how we write our answer is we start with the first number and one lower than the first degree. Okay? If you'll notice back where we long divided, it was always that case. Okay? Our answer was one lower than x squared, just x. Oh, I looked at the wrong. Well, this one was 2 lower because we were dividing by x squared, but let's look at this one. So we were dividing into x to the 5th. We came up with x to the 4th. Here we were dividing into x cubed. We came up with x squared. Okay? And that's different if we're dividing by x squared, of course, but that's not going to be something we're going to be doing very much. Okay, so anyway, so our answer is 1. Let's color code. 1 x to the 4th. And then we have 0, 0, and 0, so we don't need to mess with that. So we've got a 0 for x to the 3rd, 0x squared, 0x, and so plus 12. And then we have a remainder of 3, so that's plus 3 divided by what we were dividing by originally, x minus 3. And if you'll look back, you'll see this is the same as example 2, I believe. And we get the same answer whether we use long division or synthetic. Okay, so let's divide synthetically another time. So here we've got x plus 10, so that means a negative 10 goes in the box. And then this is written out of order, but we've got an x cubed, x squared, x 20, and so, or x to the 0. So everything's there that we need. So the 3x cubed, we put a 3. Then the 25x squared, we got the 25 next. Then minus 48x plus 20. Don't need the plus there. Draw our lines, and then we can start. So bring down the 3. Negative 10 times 3 is negative 30. And then we add. So that's negative 5. Negative 10 times negative 5 is 50. And we add. So that's 2. Negative 10 times 2 is negative 20. We add, and we get 0, which is nice. That's what we're going to like in the future. And so our answer is 3x, since this was x cubed, then it's x squared, minus 5x. Notice how we're going down in our degrees, plus 2. Okay, so why did we do all this? The first reason is to be able to apply the remainder theorem. And what the remainder theorem says is basically if your polynomial can be divided by x minus c, then the remainder is f of c. Okay? Now, what does that mean? That means if you get a remainder of 3, then f, where x is c, is 3. That may be hard to understand, but hopefully you'll see it better with an example. So we'll go back to the factor theorem there in a second. So given f of x, use the remainder theorem to evaluate f of negative 1. Okay? So, yeah, you could plug in negative 1 for x here. You could also use synthetic division. And so we're going to use synthetic division. Negative 1 goes in their box. Then you've got 5. You're missing an x to the 6, so we need a 0. Then you've got negative 3x to the 5th. You're missing an x to the 4th and an x cubed. Then we've got 2x squared. We're missing an x, and then minus 1. Okay? And so bring down your 5. Negative 1 times 5 is negative 5. Add. Negative 1 times negative 5 is 5. Add. Negative 1 times 2 is negative 2. If I get it to right. Add. Negative 1 times negative 2 is 2. Add. Negative 1 times 2 is negative 2. I'm running out of colors. Add. Negative 1 times 0 is 0. Add. go back to pink. Negative 1 times 0 is 0, add. Okay? So your solution then is, we started with x to the 7th, so we're using x to the 6th. So we've got 5x to the 6th minus 5x to the 5th plus 2x to the 4th minus 2x cubed. And then we don't have an x squared or an x. Let me make sure oh, wait a minute. We didn't even need all that. All we're doing is finding f of negative 1. So we've already done that. F of negative 1 is the remainder, negative 1. Okay, and it's just a coincidence that they're both negative 1. It could have been 3. It really doesn't matter. So if you plug in negative 1 in all these x's here, then you would get negative 1. Okay? So let's look at another example for the remainder theorem. This time we're dividing by the square root of 5. Oh, lovely. So, square root of 5 goes in your box. And just as a pre-note, you're going to want to leave space between your numbers here. So 1, then negative 4. Notice I'm leaving quite a bit of space. 20. We didn't need any zeros in there. Okay, so bring down the 1. Negative 5 times 1 is negative 5. Negative 4 plus, that was not negative 5, that was square root of 5 times 1 is square root of 5. Negative 4 plus square root of 5 is just negative 4 plus square root of 5. See what I said about needing space? Okay, so square root of 5 times negative 4 plus square root of 5. You have to distribute. So that's negative 4 square root of 5. It's supposed to be using green. Negative 4 square root of 5 and then plus 5. Okay, because square root of 5 times square root of 5 is 5. And then we add. So when we add here, then we're able to get rid of, we've got negative 5 plus 5 here. So we just have negative 4 square root of 5 left. Okay? And then when we multiply square root of 5 times negative 4 square root of 5, that is, here I'll write it out to the side, square root of 5 times negative 4 square root of 5 is negative 4, and times the square root of 5 times square root of 5 is 5. So that's where I'm getting negative 20 to go in here. And then we get a remainder of 0. Okay? So, what this is telling us then, there's more to the remainder theorem than just evaluating f of x. Okay? The remainder theorem also says that if you get a remainder of 0, so you don't have a remainder, then the number you're dividing by is a 0 of that function. This is positive, okay? You'll see this in a few minutes. This is what we need, okay? So, yes, the square root of 5 is a 0 of the function. It's a solution. It's an x-intercept. Okay, getting the idea here. If we were to graph this, then at square root of 5, 2 point something, we're going to cross the x-axis. Okay, that also means by the factor theorem, which we'll go over more in a second, it also means by the factor theorem that x minus square root of 5 is a factor And I know that wasn't part of this particular example, but might as well go ahead and look at it. Okay? And that makes sense, because if you say x minus square root of 5 equals 0, solve for x, you get square root of 5. It's a 0. Okay, let's look at another example. Show that 8i is a 0 of this polynomial. Okie dokie. Stick that in our box. And we've got 2x cubed plus 1, and might want to leave some space in here too. 1x squared whenever you're dealing with a square root or an imaginary number. Leave space. And then 128x plus 64. Okay, so we bring down our 2. 8i times 2 is 16i. Add. Well, 1 plus 16i is 1 plus 16i. Okay. Multiply. 8i times 1 plus 16i. Distribute. So we got 8i minus, or no, oh, minus 128. Yeah. How in the world did I get that? Okay. Gonna have to go to the side and look at it. So 8i times 16i. Well, 8 times 16 is 128. I times I is I squared. We have to take into account, remember that I squared means negative 1. And so that's why I said that 8i times 16i is negative 128. Okay, so 128 plus 8i minus 128. That makes the 128s go away, so we just have 8i. That's nice. 8i times 8i is negative 64. How did I get that? 8i times 8i is 64i. So that's 64, or 64i squared. That's 64 times negative 1, negative 64. And so here we have a 0. Okay, so what's our solution? Well, we don't need to write a solution. We're just asked, is 8i a 0? Yes, because the remainder is 0, because there's not a remainder. If there was, then it wouldn't be a 0. But since there isn't, then 8i is a 0 by the remainder theorem. And by the factor theorem, we can say then x minus 8i is a factor. Okay? So this is going to help us in the future when we need to find the zeros of polynomials. Okay, example 9 says, use the factor theorem to determine if x plus 4 is a factor of this polynomial. Okay, well, remember what I just said. If x minus 8i is a factor, then 8i is a 0. Okay, so if x plus 4 is a factor, then negative 4 is a 0. So that's what goes in our box. We're going to find out if it works. So we've got 6x cubed plus 11x squared minus 60x minus 32. No more i's or square roots. Yay. So bring down the 6. Negative 4 times 6 is negative 24. Add. Negative 4 times negative 13 is 52. Add. Negative 4 times negative 8 is 32. Add. So, there is no remainder, and so that means that x plus 4 is a factor. That also means that negative 4 is a 0. Okay, very important. Okay, 2 more examples. So now we're going to move on, and we're asked to factor this. Given that x minus 6 is a factor. So it already told us one of the factors, so that's nice. So, just want to see how much space I have. Not much. Okay, so if x minus 6 is a factor, then 6 goes in our box. We've got 4x to the 5th minus 24x squared minus 3x cubed plus 18x squared minus 1x plus 6. Okay, so we go through our synthetic division. I'm not going to talk through it this time because I'm trying to speed up the process a little bit here, and we've already done it several times, so hopefully you're catching on. And we do have a remainder of 0. That's good. Okay, so what this tells us is that x plus 6 is a factor with the following left: 4 x to the 4th plus 0 x cubed minus 3 x squared plus 0x minus 1. Okay? So if we were to multiply back through 4x to the 4th minus 3x squared minus 1 times x plus 6, then we would get 4x to the 5th minus 24x to the 4th minus 3x cubed plus 18x squared minus x plus 6. Okay? Okay, it wants us to continue factoring, and we can do that because this can be easily factored by grouping. Okay, so I'm going to go over to the side here. Just going to draw myself a little box. And we've got 4x to the 4th minus 3x squared plus minus 1. I know it's usually x squared and then x and then your constant. But x to the 4th and x squared will work the same way. Okay, so we've got 4 times negative 1 is negative 4. So what will multiply to give us negative 4 that will add to give us negative 3? Well, it'd be negative 4 and 1. So we put in here negative 4x squared plus 1x squared. And then we group. Remember this? So we can pull out a 4x squared, and we're left with x squared minus 1. And then for the next pair, we can't pull out anything, just a 1. And we're left with x squared minus 1. So that means that 4x to the 4th minus 3x squared minus 1 factored is 4x squared plus 1 times x squared minus 1. So we can put that over here. Okay? And you'd like to say we're done here, but we are not quite finished. We can't do anything else with the x plus 6. We can't do anything else with the 4x squared plus 1 because it's not a difference of squares. But x squared minus 1 is a difference of squares. Okay? That would give us x plus 1 times x minus 1. And now it is completely factored. This is our complete factorization of that polynomial. Okay, so for the last example, it says we're going to do something a little bit backwards. Write a polynomial of degree 3 that has the zeros 2 of multiplicity 2 and negative 5. So we're writing p of x, our polynomial, where we've got a 0 of 2. Well, if we have a 0 of 2, then we have a factor of x minus 2. And it says it has a multiplicity of 2, so we stick a 2 up there. And it says that negative 5 is also a 0, so that means that x plus 5 is a factor. And so we have written a polynomial that has zeros 2 of multiplicity 2 and negative 5 of multiplicity 1. And we can go through and do some multiplying, fooling, and fun stuff. Distribution to get this out completely. So we've got x minus 2 squared. So that would be x minus 2 times x minus 2. That gives us x squared minus 4x plus 4. And then we're multiplying by x plus 5. And so we've got to distribute through the x and distribute through the 5. And when we do that, we get x to the third minus 4x squared plus 4x. That's distributing through the x. Then we distribute through the 5, so that's plus 5x squared minus 20x plus 20. And I think there's some like terms in here. We've got some x squareds that can be combined. So we've got x cubed plus x squared. And then we've got some x's that can be combined. So minus 16x and then plus 20. And so this is our polynomial that we have found. Now, just so you know, why does it say write a polynomial? Okay, this is just one polynomial that has these zeros with multiplicities. Okay, if we multiplied through by 2, it would still give us the same zeros. Okay, so if I stuck 2's in here and so forth, I'm not going to do that, then it would still give us the same answer. Okay, or if I stuck in negative 3's or whatever. But this is an option of a polynomial that will give us those zeros. And that finally concludes sections 2-3.